In this video, we are going to prove that half of square root of 4 sine squared of 36 degrees minus 1 is equal to cosine of 72 degrees. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. I'm going to solve this problem in a more constructive approach. So I'm going to consider the following triangle because we are dealing with angles of 36 degrees and about 72 degrees. So for this triangle, the interior angles are going to be 36, 72, and 72. Just call that ABC, usual conventions. And from this we know it's an isosceles triangle. AB equals AC. Then I'm going to draw the angle bisector on the angle B. So then with 36 and 36 here. Now we've actually constructed even more isosceles triangles. Let me call this intersection D. Then from this we have lots of triangles related to 36 and 72, and in particular this part of the triangle is similar to the large triangle, the big triangle. So let me mark down the equal sides. BC equals BD equals AD, and at the same time I have triangle BCD is similar to triangle ABC. It's just because the corresponding angles are equal. Now from this, we can look at the ratios of the corresponding sides, which is BC over AB equals BD over AC and CD over BC. Now, to make things simpler, I'm going to let BC, BD, and AD to be equal to 1. So then I can maximize the number of sides that can be converted into numbers. Now for this, we have 1, BD equals 1, and BC equals 1. So now I have 1 over AB equals 1 over AC equals CD. Now at the same time, we notice that CD is actually part of AC, and AC is just 1 longer than CD. So I can write AC to be actually equal to 1 plus CD if I let the 3 black sides to be equal to 1. Then from this we can replace AB by 1 plus CD, AC by 1 plus CD, and CD. Now all the ratios are in terms of CD, and so we have a quadratic equation about CD, which is like this. Now on the other hand, this CD is actually computable. Because if I try to split CD into two halves by drawing the median of the triangle from the angle B, then looking at each right angle triangle, we actually have, say, this part to be 1 times cos 72 degrees. We're starting to get closer to what we want because our expression contains cos 72 degrees. And so because that's half of CD, so we know CD equals 2 times cos 72 degrees. Now putting that into our quadratic equation, we have 4 cosine squared 72 degrees plus 2 cosine 72 degrees minus 1 equals 0. And actually, we're now really close to what we want. If we start working from our given expression, if we try to square it, then we have 1/4, 1/4 of 4 sine squared 36 degrees minus 1 equals cos squared 72 degrees. So now, that means we want to show that 4 cosine squared of 72 degrees is equal to 4 sine 36 minus 1. And from what we have here, 4 cosine squared 72 is 1 minus 2 cos 72 degrees. And we have to show that these two expressions are equal. But that's easy because, it's 4 squared instead of just sine. But that's easy because it's immediate from the double angle identity. So 1 minus 2 times, using double angle formula, we have 1 minus 2 sine squared 36 degrees for cos 72. And simplifying immediately, you get 4 sine squared 36 minus 1. And so we have proved the required expression. Please feel free to share your ideas in the comments. Thank you for watching. See you next time.